Hello, geometry students. Make sure your workbook is out and open to page 16. We did page 15 yesterday. Yesterday we were working on midpoint. When it's graphed out, you have x's and y's, and it's really related to distance when we have x's and y's. And so what we're doing today, if you kind of preview page 16 in your workbook, there's not a single coordinate grid on here, but we are still talking lengths. So for 5A, since we're skipping number 4, for 5A, I want the length of segment DJ. So from here to here, I want to know how long this segment is. So if you remember from our distance formula, you take your x coordinates and you subtract them. You take your y coordinates and you subtract them. So that's what I'm going to do here. I'm going to take where point D is, and I'm going to subtract where point J is. Now there's a whole lot of negative numbers flying around, so I'm just not even going to bother trying to do it in my head. Yes, I know subtracting a negative is adding a positive, but my calculator's better than that, better at me at that. And I'm getting negative 55. But if I said I am negative 55 meters away from somebody, that would be all kinds of confusing because distance is never negative. So what we do is we use these absolute value bars, which if you remember means take off the negative. So just like when we do the Pythagorean theorem, we don't pay attention to the negative solution. Exact same idea here. Just chuck the negative out. That distance is 55. If I had all the little marks on here, there would be 55 little bitty steps from D to J, which is why we don't count them because that's painful. So I'm going to do now the length from J to A. So if I go from here to here, again, I'm going to subtract. The order that you subtract will not matter because we're going to take the negative off, and that'll be the only difference. Usually I go left and then right. Some people prefer to do big minus small. It doesn't matter because either you're going to get negative 80 or you're going to get positive 80. But in the end, when you take off the negative sign, everybody should be back to positive 80. So that's this length here. So then it also asks on parts B and D what the midpoints are. So if you remember yesterday's formula, the midpoint is when we averaged. So if I'm going to do JA because I'm already using my blue color here. If I want the average, I'd want to go from 20 to 60, and I'm not subtracting it. I don't want to know that half of this distance is 40. That's not helpful. Averaging means you add your two numbers and divide by 2. Well, when I add negative 20 plus 60, I get 40, which is a coincidence. Divided by 2 is 20. This means that if there was a dot at 20, this distance is the same as this distance. Specifically, they're both 40, and 40 plus 40 is 80. Let me get rid of that because I don't need that. But that is the location of the middle point. If I do the exact same thing on DJ, I'm going to average. So I'm going to take the negative 75 and the negative 20. Averaging means you add them together and then divide by 2. Well, when I add negative 75 and negative 20, I get negative 95. And this is a nice terminating number. I'm trying to find a location, so I'm just going to go ahead and do the decimal of negative 47.5. If you wrote negative 95 over 2, it would also be considered correct. So again, this is not a length. This is the location. Where would you go for the middle dot? Well, I would have to go to negative 47.5. So this distance, that looks weird, is the same as this distance, and they would both be half of 55. So this whole relationship of, oh, if I know half of 80 is 40 and 40, then I can just add those distances together is exactly what we can do to make E, the answer to E, a whole lot quicker to find, because I want the length from D all the way over to A. So yes, you could take negative 75, you could take 60, you could subtract them, you get negative 135 if you use a calculator correctly, then take the negative off. Or you could just say, well, hey, look, this part's 50, this part's 80 more. Let's just take 55 plus 80, and I'll get the exact same solution. So for part F, the relationship here is if I take the part on the left of DJ and add on the part on the right of JA, it equals the whole thing of DA. So this part plus part equals whole will be our new first reason when I have justifications like we have below. So for number 6, AB equals 25. We're going to find the value of X. So I don't have AB on here, so I'm going to just kind of attempt to make a note that this whole thing is 25. So when we start this, I'm actually not going to start with numbers. I'm going to start with what we just said, where, hey, we can just take these segments and add them together. Specifically, the segment on the left is segment AN. The segment on the right is segment NB. You'll notice I'm using 2 letters each time. And when you add segments, you get the whole segment. So if I'm adding segments, this was not given to me. Nowhere above did I have that equation written. This is called the segment addition postulate. Postulate is a fancy math word that you don't need to care about, but it's part of the name of this thing. I am adding segments together. I just said this part plus this part will give me this whole thing. I'm not using numbers yet, but it's the same idea of adding the 55 and the 80 from above. So once we have this start to our problem, we can plug stuff in. So N for AN, I'm going to put 2x minus 6. N for NB, I'm going to put x plus 7. N for AB, I'm going to put 25. When you plug things in math, remember that is the substitution property. So don't put sub because that can mean subtraction. And now we have an equation. This would be like what we did at the very beginning, I think it might have been the first guided notes I made you watch actually, where we had to just solve and say what we were doing. So I'm going to combine like terms, 2x and another x, negative 6 and a 7. Some teachers might have called this simplify. I usually refer to it as combine like terms, but they mean essentially the same thing. And then I'm going to just keep solving. To get x by itself, I subtract 1. Now, quick side note, some of you might have already been tempted to complete that left-hand side. It is always more difficult for students to figure out the right-hand side if you don't do it as you go. Which means if I realize, oh, I just subtracted from both sides, write down that you just subtracted using the subtraction property of equality. Then, if you realize, oh, I solved by division, then write the division property of equality. And every year I say this, and every year still students do it. Do not write on this right-hand side answer. I don't care if that is the answer. You will never have a reason called answer. There will always be some mathematical reasoning for why you should be doing what you're doing. So we found x to be 8. Now I want to know what the length of NB is. Well, remember NB was part of that segment. It's less than 25. So if I plug in what I know that x is, so I know x is 8. 8 plus 7 gives me 15 for NB. So we're going to have several of those that feel really similar, where I'm just going to say, okay, I can add them together. I know this part and this part. I know the whole thing. That's a bit different story here for number 8, specifically because number 8 is using the term midpoint, which remember we know means the point in the middle. So AB's length has to be the same as BC's length, which means I'm going to start out with that. AB's length has to be the same as BC's length. So it starts out a little different than this last one. The last one I added segments. I'm not adding segments here because I have no reason to add them. I don't know what they equal. But if I know that they equal each other, the only reason I know that is because I read the word midpoint and I know what the definition of that word is. That's your mathematical reasoning for that first step. It is no longer given to you because we're not in algebra class anymore. Now we're going to be using things like segment addition or the definition of midpoint. And then it picks up pretty similarly. Just like last time, we're going to use a substitution property. I'm not sure I can remember a single geometry problem that doesn't have substitution as reason number 2. So figure out something without without numbers in it, and then substitute your numbers in. So 5x minus 7 is AB, 3x plus 7 is BC. There are no like terms to simplify here because they're on different sides of the equal sign. So you actually have some options. I'm going to choose to use the subtraction property of equality because I like to get my x's together first. It is just as correct to use the addition property and move that negative 7. So this is a little more open-ended. So like I said, I'm going to subtract my 3x from both sides. So the negative 7 and the positive 7 stay put, but 5x minus 3x gives me 2x. And then I'm going to keep solving. I'm going to get x more so on its own side of the equal sign. So that 7 is negative. I'd have to add it to both sides. So I'm going to note before I move on that I got that line from the addition property of equality. And then finally, I found that x is 7 because I divided both sides by 2. So I use my division property of equality. When you do it to both sides of the equal sign, you're not just combining like terms, then you have to have one of your properties of equality. And then I do need to read the directions. It does want to know the length of AC. This is AC. So I'm going to plug back in. Well, AB is 5 times x minus 7. So 35 minus 7, which is 28. BC is 3 times x plus 7. So 21 plus 7. This is a good way to check your work. I was expecting them both to be the same because I know what the word midpoint is. If these didn't both turn out to be 28, something's definitely off. However, once you find this first 28, if you're relatively confident in your work, you can already know that this next one's 28 too. So now I can find AC because segment addition postulate lets me take AB and add on BC, and I know part plus part equals the whole thing. 56 is the length of AC. We'll do more practice of this in class, but I wanted to make sure you got these completed and filled out in your work.